Hello everyone. In this video, we are going to learn about the basic concepts of OOPS. OOPS, OOP, stands for Object Oriented Programming. When it comes to programming, we write the programs to process the data. So data is the collection of facts, statistics and figures which can be processed to generate the meaningful information. Now that means in every programming language, the data is the basic element. And in order to declare the data, we need to have the types. We call it as the data types. And in first year, we have learnt about the data types. In first PUC, we learnt that the data types are classified into the basic data types and the user-defined data types. Like integer, character, float, double are the basic data types. Whereas we have learnt about the structure, which is the user-defined data type, and the user-defined data type is created from the basic data type. Now, the user-defined data types usually have the homogeneous or heterogeneous data items. But in this chapter, we are going to learn a new user-defined data type, and that data type is called as the class. The class data type which is created using the keyword class. Now, what is the difference between a class data type and any other user-defined data type? The class data type can store the data items as well as it can store or it can define the functions that are operated on the data items. Whereas if you have any other data, user-defined data type, it can just explain the types of values that could be stored in the data type, whereas it will not store any functions. Whereas the class can store the data along with the functions. So that is the difference between a user-defined data type and a class which is also a user-defined data type. In order to understand the concept of a class, let me give one example. So let me ask one question. If I ask you, have you seen an animal? Majority of you would say yes. But I would be expecting the answer no. Why? Because the concept animal, we have to understand that it is an imaginary concept. Something imaginary, which doesn't exist in reality. So animal, I can say it has eyes, animal has ears, animal has nose, animal has legs. Okay, so along with that, I can say animal can speak, animal can listen, animal can see, animal can walk. Okay, so when I talk about animal has something and animal can do something. Now, animal is something imaginary. Animal is a class, something imaginary, and that something imaginary has certain properties. It has some properties and it can perform some functions. It can perform some functions. So then I would say, if I ask you, have you seen a cat? Then definitely your answer will be yes. Because cat is of the type animal. So animal has some properties. The properties could be this ears, it could be nose, so eyes. Okay, so the functions could be see, listen, and smell. Okay, so animal has these properties an animal can perform these functions. Okay, but I cannot just say animal you see, or I cannot just tell the animal you speak. No, it is not possible. But I need to feel the animal. So if I say animal cat, now with this declaration I say that cat is an animal, or cat is of the type animal. Now from animal, from imaginary concept, I am creating one entity, I am creating one object, and that object has certain properties, and that object can perform some operations. Now here the definition says animal has some properties like ears, nose, eyes. So likewise my cat is of the type animal, so animal has ears, nose and eyes. Animal can perform some functions like that. Since cat is of the type animal, so cat can perform some functions like a cat can see, it can listen, or it can smell. So now the class animal, I told you it is imaginary concept, and the class animal is the user defined data type. It is a user defined data type. Like integer is a data type which is given by the language. Okay, but animal type is not given by the language. So if the data type is not given by the language, if it is created by the user, then it is called as the user defined data type. So animal is created by the user, something imaginary. And then here when we say integer a, I am declaring a variable a. I am declaring a variable a. So that means a is of the type integer. That means the type will give some properties to this variable a. Similarly, when I say animal cat, a cat is declared. Cat is declared of the type animal. So cat has some properties, whereas cat can perform some actions. With this, we have understood that the class is just a user defined data type. Let me explain something more about the classes. Now class, it is an imaginary concept. The class can be defined as a blueprint. Class is a blueprint from which the objects can be created. So let me give the example of the blueprint of a house. Now assume that this is the plan of my house. Okay, so I may explain, I may show some entrance, I may show the washrooms here, or the bedrooms here, something like that, or I may show the kitchen here. Okay, now the blueprint will show you all the properties. The blueprint explains the dimensions of your rooms, the height of your house, everything it explains. But the blueprint is printed on a sheet of paper. Okay, so by having the sheet of paper, the blueprint of your house, you cannot say that you are possessing a house, you are having a house. So in order to have a house, what you need to do? You need to construct the house. So how many houses can be constructed from the blueprint? If I have a blueprint, from this blueprint, I can construct many houses. Assume that this is my first house, and I call it as H1, house 1. Whereas now I may use the same blueprint and I may construct another house, whereas the name of this house will be H2. Now this blueprint can be compared to the class, whereas these houses can be compared to the instances of the class. So what is an instance? Instance is nothing but the copy. But what is the difference between, it is not just the copy of the blueprint, it has some physical space. By constructing the house H1, I can say that I am having the house so that I can invite my friends, relatives, and I can say that the house is having some space. Now H1 is given a space and for dwelling, whereas H2 also is given a space. So class can be compared to a blueprint. It is a blueprint from which the objects are created. So here from this blueprint of the house, I have created two objects, H1 and H2. More on the classes and objects we will be seeing in the next chapter, classes and objects. But in this chapter, in the basic concepts of OOPS chapter, we are going to learn some of the terminologies used in the classes and objects, or you are going to learn some points that are very important with respect to the classes and objects. To begin with, what are the characteristics or the points to be remembered when we talk about the classes and objects? So first we need to understand what is a class. I gave the definition of a class. Class is a blueprint from which the objects are created. Then we have to understand what is the object. What is an object? Object is the instance of the class. Instance is nothing but the variable of the class. Okay, where that variable, usually the variables will have the data. Whereas these variables called objects, they are also called as objects, they have data as well as they have the functions. Next characteristics, next point that we need to understand is the data abstraction. So the object-oriented programming languages or object-oriented programs, they support data abstraction. What do you mean by abstraction? I'll give the example. For example, we all are familiar with the mobiles. We dial a number and we talk to our friends. But we just know dial the number and talk to the friends. We do not know what happens when we dial a number. So that means the phone represents the essential feature by hiding the background details. That means the background details are hidden and the essential features are shown, they are presented, and that is called as abstraction. Say for example, if I want to switch on the fan, I have a switch on the wall, I switch on the fan and fan rotates. I am not bothered how it rotates, how the power is supplied to the fan, how the motor rotates, all those things I am not worried. What I want to do is I want to switch on the fan. That is called abstraction. So data abstraction means, like actually when the programs are complex, in the complex programs, you are just given some interfaces to use and the background details are hidden from the user. So the process of hiding the essential features, process of hiding the background details and providing the essential features is known as data abstraction. So the next property of the class and object is encapsulation. What do you mean by the encapsulation? I give the example of animal. So animal is a class, something imaginary. And in that class, I have the data items. I have some properties, and these properties are also called as attributes or the data items. Okay, along with those data items, that animal class has some functions. It can perform some functions. Now, the class animal is encapsulated with the data items and the functions. So the data items show the properties of the class, whereas the functions, they show the possible operations that could be performed on the object of that class. Okay, so combining the data items and the functions in one unit called class is known as encapsulation. So the next term that we are going to learn in classes and objects is polymorphism. Poly, what do you mean by poly? Poly is many. Morph is form. So that means a function or one object can assume many forms. If the function can act in many forms, then that concept is known as the polymorphism. So in the polymorphism can be implemented using the concept called as overloading. So there are two types of overloading. One is operator overloading and the second one is the function overloading. So what do you mean by operator overloading? So in operator overloading, you are making an operator to operate upon a new type. For example, if I have a plus, plus is an operator basically used to add two numbers. So if I am able to add, say for example 3 plus 5, so that means it adds 3 and 5. If I have a string, say for example str1 and str2 are the variables of string of the type string, and if I am able to add them using the plus symbol, then I am making the plus symbol to operate the strings. String is a new data type. Basically plus is not meant to add strings. Plus is meant to add the numbers, maybe integer numbers or floating point numbers. But I am overloading the plus operator such that the plus operator can be also used to add to strings, or it can be used to add to objects of the class, or maybe to add to characters, like that. So in operator overloading, we can make the operator to work upon the new type. Then what is function overloading? In function overloading, you can make a function to behave differently based on the type of arguments passed to the function. Even the concept of polymorphism. Poly, many, morph forms, that means function is behaving in different forms. Let me explain that with an example. I told you about the animal class. Assume that animal has some properties and animal can perform some function. And I am defining one function in animal, that is move. Assume that the move function is move. Move function is defined for different types of arguments. Assume that move and legs. I am giving legs to the move function. Okay? Then say for example move, I am just giving the example, legs, comma wings. Okay? Now I am defining another function, but the name of the function is move, same, but the number of arguments or the types of arguments are differing here. Let me define one more function in class animal, say move, and assume that it is going to take different arguments, say body, and say legs, and say sometimes or wings. Okay? Now in animal class I have defined three functions. If you see these functions have the same name, and these functions, the first function is taking only one argument, the second function is taking two arguments, and the third function is taking three arguments. When I say move of legs, okay, so assume that I am declaring the objects, 3 objects. One is man, and say second one is sparrow, and third one is say duck. Now on man, and all these man, sparrow and duck, all these are the objects of the type animal. Okay, now when I say man dot move of legs, when I call the man move function, I am just passing the legs. Understood? Then which function will be called? This function is called. So that means man is walking. Okay, now assume that I have another object, sparrow is of the type animal, and I say sparrow dot move. I am calling move on sparrow. And what I am going to do? I am going to pass legs and wings. So what happens? Maybe the sparrow flies. See, man walks and sparrow flies. Okay, next I am going to call the move function again with the body, on the third object, that is duck dot move. Duck is of the type animal, and I am calling move function on duck, and the move function on duck is been given 3 parameters: body, legs and wings. Example. Okay. Now what happens? Duck swims. See, the move function in the definition, I am having the same word, but I have different arguments passed to the function, and this move function acts in different way. In the first case it walks, in the second case it flies, in the third case it swims. So that is polymorphism. The process of defining a function with the same name but with different method signature or different arguments is called as a polymorphism, which is also known as the function overloading. So using function overloading, polymorphism can be implemented. Next, we have dynamic binding. Binding. What do you mean by binding? Binding is the process of linking one program with another program using a function call. Binding is the process of linking one program with another program using a function call. So, why it is called as a dynamic? So it is called dynamic because the code for the execution is made available only during the execution of the program. So we all know the programs can have the functions, and the function of one program can be called from another program. So when I call the function of one program from another program, then I am linking these two programs. Linking is nothing but binding. So when you bind the data, the code should be made available to the program which is calling, isn't it? So it is made available only during the execution of the program. So that is called as a dynamic binding. Okay, next feature that we have to learn is message passing. So what is message passing? Message passing is the process of invoking a program. It is a process of requesting for the execution of a function. So that means you are requesting for the execution of a function. And how are you going to request? By calling a function on a particular object. Say for example, if I am going to call the move function on man, so I need to declare the object. So animal man. So man is the object of the type class animal. Assume that animal class is been defined then I can say man dot move of say legs. See, very simple, isn't it? So this is called message passing. What I am going to do, I am just requesting for the execution of a function. And which function is being executed here? The move function is executed. On which object the move function is executed? On the object man, the move function is executed. And what are the arguments passed to the function? The legs are passed to the move function, and a request, this is a request for the execution of the function, and that is known as the message passing. So another important feature that we have in object-oriented programming is inheritance. What is inheritance? Inheritance is the process of creating a new class from the existing class. So that means we have one existing class, and if some of the properties are to be used by another class along with the new features, then what we can do is we can just inherit some of the properties from the existing class, and then we can add on some properties to the new class. Say for example, we inherit some properties from our parents, and along with those properties we have some additional properties. Okay, so the properties are being inherited from the parents. So in inheritance you are going to create a new class. Okay, and how are you going to create a new class? From the existing class, so that the new class has the properties of the existing class, plus the new class can have its own properties. Okay, so that is called as inheritance. Now in inheritance, you have the class which has been inherited is known as the base class. If I am getting the property from my parent, then my parent is the base class. And the class that has been created after the inheritance is known as the derived class. So when it comes to inheritance, so you need to understand these 2 points. One is the base class and the derived class. Base class gives the properties to the new class, and the derived class takes the properties from the existing class. Now a class can inherit the properties from one or more classes. It's not that it will inherit the property from only one class or single class. It can inherit the properties from multiple classes. So based on this, the inheritance is also classified into single level inheritance, then multi-level inheritance, multiple inheritance, then hierarchical inheritance, hybrid inheritance. So like that you have some of the different types of inheritance. Students, please understand, this is just the introductory chapter, where you are just introduced to the terms that are being used in the object-oriented programming language, where you have to deal with all these different terms elaborately. There are separate chapters for all these terms, like what is the class and object. We have the chapter on classes and object. We have chapter on inheritance. We have chapter on function overloading, like that. So in this chapter we have just seen the terminology of the classes and object. Next, let us understand about the advantages of the object-oriented programming. Okay, so object-oriented programs are modularized. What do you mean by modularity? Modularity is the concept of breaking the complex program into subprograms and solving these subprograms to attain solution to the complex problem. Very simple. Assume that you have to construct a house. When you construct a house, you appoint one contractor. Contractor alone cannot manage the construction. What he does, he divides and gives the work to the subcontractors. Assume that we have a mason, we have a plumber, we have an electrician, and maybe the painter. Okay, so that means all these individual persons, they are going to do their work. And once that work is done, we have the main construction done. So breaking the complex program into the sub-programs and solving these sub-problems to achieve solution to the main problem is called as the modularity. Now, the object-oriented programs, they follow the principle of modularity so that the solution can be easily achieved, and there is a teamwork, and each person can develop each modules, and finally these developed modules can be combined together to arrive at a solution. Next, we have understood about encapsulation. So there is an advantage of encapsulation also. What is the advantage of encapsulation? The encapsulation combines the data with the function so that the data cannot be accessed outside of the class definition. It is confined within the class, confined to a class, and that data cannot be accessed outside of the class definition. So that means we can give some priority to the data, we can set some scope to the data so that the data is protected. With this, data hiding can be implemented. Data abstraction will separate the data design part and the implementation part. I told you abstraction is the process of hiding the background details and providing the essential features. So data abstraction separates the design part and the implementation part, and that is the advantage of object-oriented program. In inheritance, what happens if you have to create a new class with the existing features, then you can just inherit some of the properties from the existing class. So then what happens? The new class will have the properties and the codes which are written for the existing class. Now with this, what happens? The code reusability increases. You can reuse the code, and the code duplication is reduced. So you need not duplicate the code. So that is the advantage of inheritance. Then, or indirectly, the advantage of the object-oriented program. Then, using the concept of polymorphism, what we can do is we can make one function to behave in different forms. In our traditional system, what happens? We have many functions with different names, whereas here in case of polymorphism or in function overloading, we have many functions with the same name. Just understand that we need not remember many function names, but we need to be careful while passing the arguments. So that is the advantage, where we can define multiple functions with the same name, so that we need not remember the names of the function when they are to be invoked with the arguments. So when you have to invoke a function, or when you have to call a function, what you need to do is you have to just write the name of the function and you have to pass the argument. So compiler automatically selects based on the input arguments. If I say move legs, it makes man to walk. If I say move of leg and wing, it makes bird to fly. So that selection of the function is done automatically by the compiler. So these are some of the advantages of the object-oriented program. So what are the applications of object-oriented programming? The object-oriented programmings are used in the development of graphics applications, graphic designing applications. They can be used in CAD and CAM applications. We all know CAD is a computer aided design. CAM is a computer aided manufacturing. There are some applications for those CAD and CAM, and those applications are designed using the object-oriented programming languages. And these object-oriented programming languages can be used to design the graphical interfaces, GUIs, graphical user interfaces, like Windows operating system. Okay. The object-oriented program can be used for the simulation, and they are also used in the real-time systems. The object-oriented programs can be used in the artificial intelligence, and they can also be used in the expert systems. So these are some of the applications of the object-oriented these are some of the advantages of object-oriented programs. Now with this we have understood some of the terminologies that are to be used when we work with the object-oriented programming languages. And this, in this chapter we have understood what is a class, what is a object, then what is data abstraction, then what is data encapsulation, what is inheritance, what is polymorphism, then how the polymorphism is implemented using overloading. And in overloading we have understood what is operator overloading, what is function overloading. Then we understood about data binding, okay, dynamic binding, and then we also understood about the message passing. After that we have understood about the advantages. We learnt about the advantages of object-oriented programming, and then finally we have understood about the applications of object-oriented programming. Thank you.